Good morning. My name is Craig Steele. I'm a computer scientist, gadget geek, and interested in all things tech. This morning, I'm going to attempt to demystify the digital world. We'll talk about how important digital skills are in Scotland, and I'll introduce you to some exciting projects that are powered by code. I'll also show you how you can get started on your journey from being a digital consumer to a digital maker. Now, Scotland is facing a challenge over the next decade. Currently, there are around 11,000 digital job vacancies each year in Scotland, and around half of those posts are unfilled. There are more jobs than ever in this area, and this digital skills gap is going to be a real issue. 62 secondary schools in Scotland don't have a subject specialist teacher to deliver computing courses. And last year, SQE figures showed that in 2015, only 19% of higher computing candidates were girls, and this is a marked decline. Now, this isn't meant to be a dig at formal education, but we can't rely on the formal education system alone to solve the digital skills gap. In 2012, I started Coder Dojo Scotland. So Coder Dojo is a national network of free computer coding clubs for young people. Our clubs are run by volunteers from technology backgrounds who are keen to share their skills. At our clubs, young people learn how to build apps, design games, make wearable technology, and experiment with cutting-edge tech like virtual reality. It makes learning to code a fun and sociable experience. Here's our most recent figures. We've got a great geographic reach, and we're working with dozens of volunteers and hundreds of young people across Scotland each month. At the end of last year, after the launch of Coder Dojo Isla, our total clubs came to about 28 across the country. So there's clearly an interest in young people learning these digital skills. The Coder Dojos here in Inverness and Moray are some of the most popular clubs in the country. Robert and Claire and their team of volunteers have done a fantastic job establishing and delivering this brilliant opportunity for local young people. But that doesn't mean we just have to leave it to the kids. My role is to help develop that next generation of digital makers. Now, many people wrongly assume that everyone these days is a tech wizard. We might be digital natives. Many of us have grown up surrounded by devices. But not everyone understands a bit about how they work underneath, or more importantly, how they can create their own digital content. That's the difference between being a digital consumer, so someone who uses technology, browses the web, plays games, and being what's called a digital maker. We should give more people the chance to be makers, not just consumers of digital content. So to do that, you need to learn a bit about code. So, what is code? So, computer code is a set of rules or instructions that a computer uses to complete a task. Coding, or programming, means writing those instructions step by step that tell the computer what to do. Those instructions are called a computer program. In real life, we follow instructions all the time to complete tasks. So, has anyone baked a cake recently? Yeah? So if you did that, you probably followed a recipe, which is just an example of a set of instructions. What about creating sort of like flat pack furniture or something like that? Has anyone had to do that recently? Yeah. Well, you probably followed a set of instructions as well. Or, well, if you didn't, then I would just be careful the next time you sit down. So programmers write their instructions using computer programming languages. And there are thousands of different languages that are useful for completing different tasks. Now, some people think that computer code is all written in ones and zeros, that would be all gibberish. However, most programming languages, they look like this. They look like English. They use English-like words and phrases. And just like our languages, they follow rules and grammar. Once you've learned the rules, you'll be able to read and understand code as easily as reading a book. Now, becoming a master programmer can take a lifetime. But reading and understanding code is much simpler. Just like you did in school, before you can write your own code, you practice by reading and understanding code that's been written by someone else. So this is code that I've written. So in my flat, I have lights that are controlled over the Wi-Fi connection. And this is the code that I've written that turns the lights on and off depending on what the sunset is that day. So it's written in a language called Python. I'm not expecting you to understand it all, but if I point out bits of it, you might be able to get a feeling of what's going on. So I have to tell it the name of the city. So I live in Glasgow. And then I have a bit down here that says sun, city.sun date, and it's got today's date. What that means is, in this variable called sun, I hold the times of sunset and sunrise on this specific day, which is today. Then I have another variable called now, and that stores the exact time that it is now, because this code gets run over and over again in my house. Now we've got a little bit of logic, so an if statement, so you've probably seen that in things like Excel before. And it says, okay, if now greater than sunset. So if the time just now is greater than the time at the sunset, it's going to run the next part of code. Otherwise, it wouldn't do that. So what I'm saying here is, if now is later than sunset, so if the sun set, it will run the next bit of code. The next line, it connects to my bridge, which is the little computer that I have sitting in my flat that connects to all my lights. And it says, I want you to get all the lights that you can find in that house, and I want you to put it in a list. So I've now got a list of lights. And then I use a for loop. So this is a loop that repeats the same bit of code over and over again. So what this is saying is, for each light in my list of lights, I want you to turn the lights on, and I want you to make the brightness full. And it repeats that for every item in the list. So again, it's only about 20 lines of code. But again, I'm not expecting you to look at that and be like, great, now I know it all, I understand it completely. But it's maybe more understandable than you thought it was. You can see how these things might work, and you can see how maybe you would change it to work with you. You'll be surprised how quickly you can pick up these types of things. Because you don't need to be a genius. Anyone can code. Computer programming, here's a spoiler, computer programming isn't as complicated as some people make it out to be. But there are a few key skills that you need to have. And in fact, you might be doing some of these things already. When writing code, you need to be able to think through a solution step by step. Many computer programs don't work at first because the instructions are in the wrong order or they are doing the wrong thing. So if you are good at thinking through a problem step by step logically, that is a vital part of programming. Even a small mistake in your code can make it behave in a different way than you expected. And eagle-eyed coders can spot out spelling mistakes and other small errors that stop their code from working. So if you've got great attention to detail, you might be a good computer programmer. That's a great skill that you need to do that. Every coder gets frustrated when they run their code and it doesn't work. So an important skill is to be able to go back through your code and try and spot those mistakes. So those mistakes are called bugs. And debugging your code might be tricky at times, but it's worth it because when you finally catch that bug and your program works. If you do these things as part of your normal work in life, you might find that you're naturally a good programmer. Many of the people that I've run programming workshops before are surprised. They've never tried this type of thing before, but they try it out, and they're really good at it the first time. They give it a shot, and they've seen that it was something that it was good at, and maybe they want to take further. It's a skill that is worth developing. And there's never been a better time to start. Because we are living in a digital world. So many of our businesses are creating digital products or delivering services digitally. We shouldn't just think of the digital makers as those geeky people sitting in bedrooms or those traditional tech companies. We are all in tech companies now. As well as the problem-solving skills I spoke about earlier, think about how you can use this as a practical skill to allow you to make a difference in your own line of work. Consider a future where more teachers, nurses, or civil servants had a greater understanding of technology, and they could improve their practice by building their own digital solutions to problems. Let's look at some areas where digital skills are becoming increasingly important. So one of them is medicine. The picture at the top left there, that's a pill dispenser. It was created by a primary school in England, so made by young people, and it was built using Lego and a Raspberry Pi computer, so that's just a small miniature computer. They built it because they were doing a project about helping or finding out a bit more about people who had dementia and what they could do to help people. So they built this as a way that if someone was, suffering from dementia and they were maybe forgetting to take their medicine, this is a tool that could help them do that. So they wrote the code that would release the correct dosage at the right time so that the person would know to take it. It also had a little timer connected into it as well, and the box was connected to the internet. So it could alert a family member if Grandad hasn't taken his tablet today, it could send out a message to let them know. I think this is brilliant. This was young people creating a digital product that helps older people live more independently. Then we've got a robot here at the top right. So during the Ebola outbreak, robots were used to help medics get out of protective gear. So that reduced the risk of spreading the virus further because they didn't need a human to help them take it off or put it on. What a fantastic use of robotic technology. I mean, I'd really love a robot like that to help me get dressed in the morning sometimes. 3D printing at the bottom left there. So it used to be that 3D limbs were expensive to produce and they were uncomfortable for the patient. But now using 3D printers, it's easier than ever to make them, and you can customize them specifically for the owner. Also, if a surgeon was going to perform an operation on a specific organ, they could do a 3D scan of that organ, and then they could actually get that scan and they could practice on that replica of the heart that they're going to be working on. So that's going to reduce the sort of time it's necessary to prepare for these complex operations. And it's going to mean that if you've tried it out before, if the surgeon's actually tried on the replica version of the heart, they've got a much better chance when they're doing it for real. So it might be that you enjoy helping people, or you enjoy working in, or you fancy a career in healthcare. Well, actually, you could do that not just by being a nurse or a doctor, but by being a computer programmer. You could feed into that as well. Wearable technology is also really popular these days. So this is the idea of technology that's built into something that you wear. We spoke about Fitbits and Apple Watches earlier. But wearable tech can also be used to tackle accessibility issues. So at the top left, that's a bat jacket. And it's designed for people who are visually impaired. It's got sensors in the jacket that are ultrasonic sensors. So it can detect if you're coming near a wall or an obstacle, and it could buzz. We've also got a bike jacket down at the bottom left there. And it uses another sensor called an accelerometer to tell how fast you're traveling. And then it uses EL wire, electronic wire, to display that speed on the back of your jacket, making it safer for road users, because road users can see what sort of speed you're traveling at. There was this company called Cute Circuit. So they made this skirt that is basically covered in LED lights, and you can send it messages, you can display images, you can have messages displaying across the front. I didn't believe it when I saw it. I saw the person wearing it, and she said, yeah, if you tweet me, it'll work. So I tweeted it, and yeah, it worked. My name went right across her skirt. But it doesn't. Wearable technology doesn't need to be expensive. So this is a BBC microbit. So this is a small palm-sized gadget that you can control with code. I was part of the team that built this, and last year there was 2 million young people across the UK that got given one of these. So on the front, it's got LEDs, and it's got buttons. It's got an accelerometer, so it can tell if you move or you shake it. And it's got a temperature sensor, and it's got Bluetooth built in as well. In fact, this is so good that you could actually make your own bit of wearable technology using this in about 30 seconds. So let's try it. So for any programmers in the room, this is a common nightmare. You might have live coding, so let's give it a shot. So I'm going to do this using a visual programming language. So that means you don't need to learn lots of the code. You can use these what's called blocks of code, and we can just snap them into place. So if I take this little block that says forever, I'll just make that a little bit bigger so you can see it. It's going to run this code over and over again. And then I'm going to hit basic, and I want it to display a message on the screen. So let's have it display HD extra 17. So I can test this code. I can hit run. And on the right-hand side, we've got a little simulator, so we can see what that would look like. But if I want to actually upload it to the microbit, I would just plug it in. And then I'm going to hit compile. Hopefully it's going to download it.
Uploading to microbit.
That's a good sign. Flashing light means it's working. Great, so if I unplug this, and plug in the battery, there you go. Got a bit of wearable technology that we made ourselves within about 30 seconds. Great, you can pass that round. I'll come back and get it at the end. Thank you. Also, art is another area that's becoming really popular to use digital technology to create pieces of art. So that could be actual digital art itself, like graphics or animations, or it might be augmenting art from other art forms, but using digital tools. So you can combine artistic skills with your digital skills to create things that would have never been possible before. So last month, I was working with a group of students from Glasgow School of Art's Interaction Design course, and it was brilliant seeing some of the new pieces that they were creating using technology. Here's some other great uses of digital technology in arts. At the top left there, this was an exhibition that was at the Barbican in London called The Rain Room. Did anyone happen to attend The Rain Room? A couple of people. So how it was a room that was completely raining in, so it rained at all points in the room, but it had sensors. So as you started to walk through the room, the rain would stop right in front of you. So you could walk through this entire room of water, but you would never get wet. It was a really strange experience. I kind of wish we had something like that in Scotland as well sometimes. At the bottom left here, this is a matrix of lights, a selection of lights that change color in response to Twitter trends. So it was doing semantic analysis and working out what were people talking about. Were they positive things? Were they negative things? But this was the idea of taking something that was happening in the digital world and using that to reflect that it was something happening in the real world. You can even create music using computer code. So Sonic Pi is a new way that you can create music and sounds using computer code. You write the code for how you want the sounds to make, how you want the music to sound, and then Sonic Pi plays it. Now, most other digital tools that you use for creating music, you do all the work in advance. You pull in the sounds that you want, you prepare it, you get it all the way you want it, and then you hit play. Then you hit record, and you've got that saved version of the file. But actually, Sonic Pi is more like a musical instrument. You play it by writing the code and changing the code as part of a live performance. So this is what's called live coding. You don't necessarily do all the digital work in advance. You actually have to do it live. So I thought I'd give it a shot today. And you don't have to be musical. Like, I'm not from a music background, I'm a programmer, but I've been playing about with Sonic Pi, and it's a really good tool to make some noise. So let's see if I can get this working. Cool. Okay. Some drums to start with. But the difference is here, the code changes as you do it. So you can change it live and it will change the way that the music sounds. So if you were a pop star, what would Taylor Swift do if she could code? So let's have a look. Do you know, I've never had a round of applause for writing lines of code before. I think I should start doing that more often. So yeah, we've looked at some of the different ways that you can use code, and actually, hopefully this has inspired you about how you can actually get started and working in this area as well. So I invite you to talk to me today about ways that you can use computer coding as part of your job, just as a fun new hobby. To bridge the digital skills gap, we need to challenge what people think about technology. We need to show that computer coding is not just for techies, but it's for everyone. Most importantly, we need more people who have an understanding of what is possible using code. Now, they might not be the ones building it, but they need to know a bit about what's happening underneath. It's not magic, it's code. Okay.